So what we're going to do next is we're going to just do some examples of simplifying trigonometric expressions and then some examples of verifying trigonometric expressions, or I'm sorry, trigonometric equations. To do that, what you're going to want to be looking at is the handout, because the key to doing these things are going to be using the identities that we've just kind of stated and proved. So you'll want to have that out sitting next to your notes to kind of refer back to. We'll really only be looking at the first page. The unit circle on the back is not going to be useful to us. We're only going to be wanting to look at the identities. Gabby, am I good to scroll? Okay. Yep. So, example. So we're going to start by simplifying trigonometric expressions. And I'm going to just kind of do a bunch of these, and they'll start off kind of easy. And, oh! Yeah, sorry. I didn't even see you sneak in here. I don't know. It's fine. You had a pass. I looked at it. It was green. We'll start off with some that are very easy to simplify, and we'll work towards some things that are a little bit more complicated. Yeah, of course. Yeah, you'll need that. Take that with you. So let's say we want to simplify the expression sine x times cosecant x. Well, let's look at our sheet of identities and see what we want to do. So what is even possible? I'm going to look for things where I have sine x equals to stuff or cosecant x equals to stuff, and see what are my possible options there. So I see 4 possible identities to use. Do you guys agree with that? Let me go, and then we'll come back. Okay, you're on the right track. So I see 4 possible identities I could use on this. I see that sine theta is equal to 1 over cosecant theta. I see cosecant theta is equal to 1 over sine theta. I see that sine theta equals cosine of pi over 2 minus theta. And I see that cosecant theta is equal to secant of pi over 2 minus theta. Now those last two don't seem very useful to me, because the other expression, neither expression has a pi over 2 minus theta in it, right? So I'm going to ignore those, and I'm going to focus on the first 2 that we talked about. So let's say we use the first one, and we rewrite sine x as 1 over cosecant x. And then let's suppose that we don't do an identity on the first one. If I multiply 1 over cosecant x times cosecant x over 1, what am I going to get there? 1. Alternatively, suppose that instead of writing sine x as 1 over cosecant, I decided to write cosecant as 1 over sine x. In that case, when I multiply those two things together, I get 1. What would be a bad thing to do? That's applying both properties. And why is that a bad idea? Has anything canceled? No. So you got something that not simpler. It's just as complicated as before, right? In fact, it's more complicated because now it's in a fraction. So instead of just having multiplication as an operation, you have multiplication and division going on. So you've actually made things worse. So this one, you would not want to do. But either one of these first two would be correct. Do you have to do it both ways? No. One of the two would be sufficient as a correct answer. Let's do another. Let's say we have the expression tangent x times cosine x. What about this one? Does anybody see an expression or one of these identities that might be useful to us? Somebody want to yell one out that you think is going to be the one to use, Michael? Quotient 1, yeah. So which one of the two parts are you going to want to use? Yeah, so Michael says that what I want to do is I want to rewrite tangent as sine x over cosine x. Because when I multiply those together, what is going to happen? The cosines cancel to leave me with just sine x over 1 or sine x. Yeah, so if it's just a label, like a variable label, like a formula with a theta in it, it's the same as the formula with x's everywhere, or y's or k's or z's or taco or whatever you want to use as your variable symbol. You may. Let's do another. So what if we have 1 minus sine x times 1 plus sine x? It doesn't seem like there's a good identity to use at my first glance. You guys kind of agree that looking at the identity sheet, there's nothing that screams out, I'm going to be incredibly useful in this situation. So what might we do first instead? I would go ahead and do the multiplication. I would FOIL this out, because this looks very much to me like a foiling problem, right? If I have one binomial multiplied to another binomial. Okay, so let's start by doing that. And when I simplify those down, what do you notice is going to happen? Good. Sine x minus sine x gives me 0. So I'm left with just 1 minus sine squared x. Now I'm going to take a second look at my identity sheet because I still haven't used an identity in this problem. Do I see an identity that might be useful here? Is there an identity with a sine squared in it and a 1? I see one. It's the Pythagorean identity. But it doesn't say 1 minus sine squared on either side, right? What it says is sine squared theta plus cosine squared theta is equal to 1. What could I do with this identity, though? What if I subtract sine squared from both sides? Aha! So what can I say about 1 minus sine squared x? That's cosine squared x. I started with the first Pythagorean identity, but I rearranged it to get this thing, and that is the identity that I used to go from that step. Is that okay, Julia? I heard yeah and then a lot of mumbling. Oh, sure. Yeah, that's fine. Again, this is the first time we're seeing this, so it's okay. We'll go slow. We'll do lots of examples. They'll get kind of gradually sneakier as I go. As you saw, the first ones maybe were relatively straightforward, and this next one, part C, was a little bit sneakier. And they'll kind of get, as I go, I'll get sneakier and sneakier to a point, and then we'll just stop getting any sneakier, because at some point you reach maximum sneakiness that you want to cover. All right, what if we have Sure. Okay. Okay. So let's start this over, and we'll just kind of show you it again. So I looked here, and I saw I have a 1 and a sine squared in it. So I went to my identity sheet and saw, well, the closest thing I've got to that is the first Pythagorean identity that says this. But this isn't exactly what I have, right? Because my sine squared and my 1 are on the same side. So I'm going to rearrange this identity to get what I want. I'm going to start by subtracting the sine squared from both sides. That's going to give me this. And if I look now, this is exactly what I have here, right? Short of the variable names being different. You agree? So now I'm going to apply this identity to say that 1 minus sine squared x is cosine squared x. I know. Talking is hard. I've been doing this all day, guys. Julia, do you feel better about that? Okay. Let's take a look at the next one. That is a plus sign there. If there's no symbol there, it's multiplication. That's what we're talking about right there, correct? So this looks rather scary to me at first glance. I have a sine cubed all of a sudden. I know, looking at my identity sheet, I have nothing involving a sine cubed, which is a little bit terrifying. But if I look, I notice that in the first term and the second term, I have a factor in common to each of them. What is in common to each term? A sine x. So what I'm going to do is I'm going to factor off a sine x. And I'm hoping then what's left is something I can use an identity with. When I factor the sign off from the first term, what do I have left? Sine squared x, good. And when I factor the sine from the second term, I have a cosine squared x. You're dividing when you factor it off. Right? Similar to if this was like x cubed plus xy squared. Right? Same idea, just instead of now being x and y, it's sine x and cosine x, right? So it's just like a different variable name, but it's the same kind of idea. Now I'm going to take another look at my identity sheet. So I did something algebraically, and now I'm going to look for an identity involving some of this stuff. Does anybody see a good identity to use? Yeah. Sine squared plus cosine squared is one of my identities. What's that equal to? So I have sine x times 1, which is just sine x. And now that I've gotten this to a single trig term, can it get any simpler than one term? Nope. So I'm done. That is this whole string of things. So it's this thing is equal to this, is what we found in the end. Is that okay, Megan? No? Yes? Maybe? So this looks really horrible, right? Yeah, you write it down first. That's a good idea. It feels like it just keeps going. I mean, there's 6 things on there. I mean, it is finite. It doesn't go on forever. It's a lot of letters. It's an alphabet soup of confusion. One person thought that was a clever metaphor. I appreciate the pity giggle. Okay. So this looks pretty terrifying because, well, it looks like I have a million different possible things, right? My suggestion in a situation like this, where it's all multiplication and you have a lot of stuff, is I'm going to use my identities to rewrite everything in terms of sine and cosine. Okay with that plan? Yeah, so if I go and look at my identities, I'm going to look for a way to rewrite cotangent in terms of sines and cosines. What is cotangent the same as? It is the same as cosine over sine. How can I rewrite sine x in terms of sines and cosines? You don't. It's already in terms of sines, right? How about cosine? Same thing. What about tangent? How can I rewrite that with sines and cosines? Yeah, sine over cosine. And then how about secant squared? Right, but now we have an addition in there, and that's not helping. What I'm going to do is I know that secant theta is 1 over cosine, right? So secant squared theta is 1 over cosine squared. Right, yeah. Is everybody okay with that idea? And then cosecant is 1 over sine. Okay, now let's look for things to cancel. So no, we do have one thing left. It's not. I crossed the squared off. Ethan? Okay. So, do we need to go back? Okay, we'll go back and do it in real time. Give me. Uh-oh, too many things. Okay, so let's start crossing things off. So I notice that I have a sine and a sine. Those can cross off, correct? I have a cosine and a cosine. Those could cross off. Another sine and another sine. And then I have a cosine that can cancel the squared on the cosine squared. So the numerator is only got ones in it, and the denominator only has a cosine x in it. And 1 over cosine x is just secant x. Everybody okay with that? So the multiplication only ones are usually the easier ones. Well, when you cross something off, it becomes 1. Wasn't the smartest question you've ever asked, but that's okay. Keep asking them. Let's do some more. I still have like 20 minutes left here. You think we're done for today? She is. He is. I think they're probably just going to get to go home. Yeah. Mr. Cater's probably just saying, you know what, you've done enough school today. Why don't you go home? The problem is you're paying to be here. Well, someone important to you is paying to be here. You know, so it's kind of stealing your money if you send you home early. You'd rather, would you give more money not to come? You pay double tuition, you don't have to come to school at all. Yeah, that makes sense, right? Yeah. All right. So let's look at example F here. It does look a little like a backward 7. That's supposed to be the letter F. I don't know how much that says about my penmanship or your brain state at this current time, but it is the last hour of a block day, so. Okay. So if I look at this, is there any obvious identity to use? Okay. I C2. don't see that one. I see someone saying that this is the same thing as tangent. So you can't do that because this is not a multiplication symbol. Well, then you have plus -1 times sine over cosine. So I agree that Q1 works, and I agree that it's not incorrect to do. The problem is, what do you do after that? Because you still have a subtraction problem. What? Well, this thing, what are you trying to say this thing is? Okay. It's okay. Let's regather ourselves here. I am not going to do any identity first. So to simplify this, the first thing I'm going to try to do is write it as a single thing. So the way that I'm going to do that is by making a common denominator. Yes, exactly right. So what will that common denominator be? 1 minus sine x times cosine x. So I'm going to take the first fraction and multiply the top and bottom by cosine x over cosine x. And then I'm going to take the second fraction and multiply it by 1 minus sine x over 1 minus sine x. Just making common denominators is all we're doing right now. Like that. So the common denominator is going to be 1 minus sine x times cosine x, right? So to turn this denominator into that, it needs a cosine. And to get this denominator, that it needs a 1 minus sine. Everybody agree with that now? Okay. So let's multiply the first fractions together. When you multiply fractions, you multiply top to top and bottom to bottom, right? You could, but then you're back to exactly what you started with, and you don't have a common denominator. But you still don't have a common denominator. And then you are left with exactly what we started with. So that's the first fraction when I multiply it together, right? Everybody agree with that? And when I multiply the second fraction together, what are we going to get? I'm going to get sine x minus sine squared x distributed. I told you they were going to get progressively sneakier. Now I'm going to write this as a single fraction. Yeah, it kind of seems that way. Or sneeze happy. I wrote the bracket there, Selena, because that negative sign needs to apply to the entire numerator. No, because then you wouldn't have common denominators. I mean, you could, but it's not going to help you. Well, not yet. Well, I am actually trying to shoot for the easiest way to do this right now. Okay. So, up to this point, what is really all we've done here? We just added fractions, right? That's really all we've done. Now, you'll notice now that I have one thing, right? I have one single fraction now. It's a gross, nasty-looking fraction, but it's just one fraction. Now I'm going to start looking for some identities to use. There's a good one. What can you cross out? You can't, because it's not all multiplication in the top. There's a good one to use. Yeah, take a second and look. Maddie, what were you going to suggest? Yes! We have a cosine squared plus a sine squared. That is 1. No, it's 1 minus sine x. What is sine squared plus cosine squared? 1. It's 1 minus. Because this, which now you can cancel the, it's 1 over the numerator. When we cross them off, they become 1s, which is so when Luke, let's say we have 2 over 2, right? When that is the same thing as 1, right? We cross them off and you get 1 over 1, or just 1. You good with that? Okay. It's, you know what? It's one of those things like sometimes it's so obvious, but it looks strange with the new symbols that it's just got to draw an analogy back to something you already know how to do. You may. All right. Let's stop here.